All right, let's look at section 7.4, which is on the 6 trig functions. So really, in this section, we've got 3 new trig functions to look at. This is actually a pretty short section because it's just a few definitions and then a handful of examples. So let's look at this. We already know sine, cosine, and tangent, and there are 3 additional trig functions, and all of them are the reciprocals of the functions that we already know. The secant is defined as the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So you can define these in terms of the sides of the triangles if you want to. Secant, since it's reciprocal of cosine, is hypotenuse over adjacent. Cosecant is hypotenuse over opposite, and cotangent is adjacent over opposite. So what I would suggest is don't memorize this stuff right here. Just memorize SOHCAHTOA and memorize the reciprocal relationships here. Now, another thing that's worth memorizing is tangent is sine over cosine, and if you know cotangent is the reciprocal, cotangent is cosine over sine. So we can come down here and look at the unit circle, and if we pick a point on the unit circle, if this is the angle T, we know that this is has x coordinate cosine T, y coordinate sine T, and of course the radius is 1. So if you wanted to, you could talk about this being secant is going to be, secant of T is going to be 1 over x. Cosecant T would be 1 over y. And interesting thing here, tan T is actually the it's the slope of this line, because tan is let's see, tan is sine over cosine. I guess that would be sine T over cosine T. So that's y over x. And that's the slope of that line there that goes the terminal side of the angle T. So tan is y over x, and so cotan would be x over y. But again, honestly, I'm doing this stuff thinking of it in terms of sine, cosine, and tangent, and using the reciprocals when I need to. Let's do a few examples. Find the secant of 5 pi over 6. All right, 5 pi over 6, I'm going to draw my unit circle here. This is pi. So 5 pi over 6 is going to be over here. So its reference angle is going to be pi over 6. Now we're asked to find the secant of this thing. So since we're asked for secant, let's do the cosine, and then we'll just take its reciprocal. So let's see, cosine of pi over 6, we know that to be root 3 over 2. Now we're in the second quadrant here. And remember on this thing, a simple trig chart, remember this tells you about all sine, tangent, and cosine. So don't try to use this for secant or cosecant, because that will mess you up. Cosine, since we are in this quadrant here, cosine of 5 pi over 6 is going to be negative, and the number is root 3 over 2. And so secant of 5 pi over 6 is going to be minus 2 over root 3, or minus 2 root 3 over 3. Either one of those is fine with me. I don't care if you leave a radical in your denominator. Okay, let's do another one. Cotan of 240. Okay, 240 degrees. Let me move this a little bit. 240 degrees This is 180. This is 270. So 240 is going to be in between. It's going to be further down here. So this is 240 degrees. And our reference angle here, go up to the top and write it, theta ref is 240 minus 180, so that's 60 degrees. All right, so what is, oh, and we're in quadrant 3. So tangent in quadrant 3 is positive. But let's see, what's the tan of 60 degrees? I never can remember that, so I'm going to grab my calculator. I'm going to put in 60 degrees and take its tangent. Now, this gives me an answer of 1.73. That's the square root of 3. Okay, and we know that tan of 240 is going to have the same number, and that's where I'm going to use this. We're in the third quadrant, so this is going to be positive. I'll put a plus there just for emphasis. And so we're supposed to find the cotan. I guess I kind of did this without saying. I found the reciprocal of cotan, which is tan. So cotan of 240 is root 3, or is the reciprocal of this. It's a 1 over root 3. And you can rationalize that if you want to by multiplying by 1, and so you get root 3 over 3. Again, I'm fine with that, or this is your answer.